We got that. Now, simultaneous equation using determinant method. How do you solve simultaneous equation using determinant method? We call this method Crammer's rule. All right, Crammer's rule. We have simultaneous equation of order 2. We have of order 3. So we are going to look at two equations in two unknowns. That is order 2. Two unknowns. When you have two unknowns, given that a11 x plus a12y equals to c1, a21x plus a22y equals to c2. Now remember that x here is unknown, y here is unknown. Okay, so this c they are constant. Now where these all of these elements, this and this are all constant. To solve for x and y using determinant method, we put the coefficient in determinant form as follows. We have to put the coefficient in a determinant form. The coefficient of s in this first equation is a11. The coefficient of this x in this second equation is a21. So we have to extract their coefficients so that we can put them in a determinant form. So find the determinant of, this is a sign of determinant. This is another symbol for determinants too. This is going to be equals to a11, a12, a21, a22. Why do we have this? Because this first one is this one. This second one is this one. Then for y, this first one is here. The second one is here. So we found this determinant or this particular structure from this equation. That is how to form it. You extract the coefficient. These are the coefficient. These are the coefficient. This two is the coefficient. So we are going to be using C1 and C2. I'll show you how to use. Then determinant with respect to x. If you are finding this determinant with respect to x, you discover that the column of x will be replaced by the constant C1 and C2. So if you are finding this determinant with respect to x, now it's going to be, instead of putting the coefficient of x here, you replace them with C1 and C2. Then you have to obtain, I say it's obtained by replacing the column of x, which is this, by this. So for determinant with respect to y, it's going to be replacing the column of y with the constant c1 and c2. Okay, and then that is how to find their single determinant. Then divide determinant with respect to s by this single determinant to get x, to get the value of s. Then determinant y by this single determinant to get value of y. Therefore, x is equals to determinant with respect to s all over the single determinant, and y is equals to determinant with respect to y all over single determinant. So this is the general structure of how to find determinant of that has two unknowns, x and y. All right, now let's look at this example, example 5. Or example, use determinant method to solve the following simultaneous equation. This is first one, this is the second one. X plus 5y equals to minus 3. 2s minus y equals to 5. Okay, let's solve this first one. If you want to solve this now, you have to change the whole thing into a determinant form. So the single determinant is going to be, the coefficient of s here is 1. That is the 1 here. Coefficient of this x here is 2. This is a 2 here. All right, for column x. Then look at this, here belongs to s, here belongs to y. So the coefficient of, in the first equation, the coefficient of y is 5. This is a 5. The second equation, coefficient of y here is minus 1. This is minus 1. All right, so the determinant, the single determinant of this equation is going to be 1 times minus 1 is minus 1. Then minus 5 times 2 is 10. So minus 1 minus 10 is minus 11. That is a single determinant. So determinant with respect to x Determinant with respect to s means the column of x, you will replace it with this constant minus 3 and 5. Minus 3 and 5 are not coefficient of any of these unknowns. Okay, so they are there on their own. If you are finding determinant with respect to x, use two of them to replace where the value of s, the value of the coefficient of s are before. So that is why instead of writing 1, 2, we replace 1 and 2 with minus 3 and 5. 5 and minus 1 still retain their position because they belongs to y. And what we are looking for is determinant with respect to s. So now this is what it means. Minus 3 times minus 1 is plus 3. And 5 minus 5 times 5 is 25. 3 minus 5, 3 minus 25 is going to give us minus 22. So that is, so the next one is determinant with respect to y. With respect to y, you discover that the value of x is intact now, 1 and 2. Then the value of y, we have to replace it with the constant 3 minus 3 and 5. That is why instead of writing 5 and minus 1, we wrote minus 3 and 5. So the determinant will be 1 times 5 is 5. Then minus 3 times 2 is minus 6. But the minus that react when you are taking a determinant will be here. So minus and minus of the minus, that minus and the minus of the 6 will be plus. So 5 plus 6 is 11. So therefore, to find the value of s, you are going to divide, it's going to be determinant with respect to s or divided by the single determinant. Alright, so determinant with respect to s, we find it to be minus 22. So minus 22 all over the single determinant. Single determinant, we find it to be minus 11. All over 11 minus 11. 11 divided by minus 11 is going to be minus 1. That of s with respect to s is minus 22. So minus 22 divided by minus 11 is going to give us 2. Because minus will cancel, minus 22 divided by 11 is 2. Also, if you are finding for y is equals to determinant with respect to y all over the single determinant here, which is going to be equals to determinant with respect to y is 11. The single determinant is minus 11, which we find here already. So therefore, 11 all over minus 11 is going to be minus 1. Minus 1. So therefore, this is what we have. So if this is the case, now, if this becomes the case, you discover that what you are going to have here is the three equations in three unknowns. What of if this simultaneous equation have three unknown, x, y, and z? The same method follows, only that you are going to take z into consideration. Now, the single determinant of this equation is just, you have to extract. See the coefficient of x, you have to extract them. In the first column belongs to s, second column belongs to y, third column belongs to z. Alright, so look at, this is the coefficient of s, is what we brought down here. Coefficient of y is what we brought down here. Coefficient of z is what we brought down here. Alright, so from here, of course, this is a 3 by 3 determinant now. Of course, I've taught how to find a determinant of order 3 by 3. If you are finding difficulties with it, you can go and watch that video, how to find determinant of order 3 by 3. So now we have determinant with respect to x. Determinant with respect to s means the column of s, replace the column of s with the constant c1, c2, and c3. Alright, so determinant with respect to y, the same thing happen. Column of y is replaced by c1, c2, c3. Also, determinant with respect to z, column of z is represented by c1, c2, c3. So therefore, determinant, the value of s will be determinant with respect to s all over the single determinant. Y, value of y will be determinant with respect to y all over the single determinant, and that follow for z. Alright, so now look at this example. Solve the following simultaneous equation using determinant method. I have two here, I have one here, I have two here. So I may solve one and then you try the second one yourself. Alright, the first one, the coefficient of, let's extract them now. The coefficient of this x is 1. Coefficient of this other s is also 1. Coefficient of s here is 2. That's what we have here. Coefficient of y in the first equation is 3. Coefficient of y in this second equation is minus 2. Then coefficient of y in this third equation is 3. That's what we have here. Then the coefficient of x, z, in this first equation is minus 2 here. Second equation, the coefficient of z is 2. That's what we have here. Then the coefficient of z in the third equation is minus 4. That's what we have here. So we need to find this determinant now of this order 3 by 3. So it's going to be 1 here into, cancel the first row and the first column, minus 2, 3, and minus 4 is what we have here. Alright, so we have minus 3 down here. It is minus 3 because this is a 1, 2, and 1, 2. Of course, I've taken time to make video on that. You can watch it. This is minus 3, and in bracket, in absolute form, we have the first row is cancelled, and then the second column is cancelled. So we have 1, 2, 2, and minus 4, and that's what we extract here. 1, 2, 2, and minus 4. Then we have minus 2. Minus 2 is here should be plus 2, but this minus that is attached to this element 2 override the plus, so we have minus 2, which is 1, minus 2, 2, and 3. Because this first row will cancel, and then the second column, the third column will also cancel. So we have 1, minus 2, 2, and 3. That's what we have here. So by the time you go like that, you discover that this one into 1 minus 1 is what we brought down here. Minus 2 times minus 4 is 8. Then minus 2 times 3 minus, we have to write this, minus 2 times 3 is 6. Then minus 3 is what we brought down. 1 times minus 4 is minus 4. Then minus 2 times 2 is 4. Minus 2 is what we brought down here. You discover that 1 times 3 is 3. Then here should be minus, but minus 2 times 2 is minus 4. Then the minus of the reaction of the determinant here is plus the minus that we have at hand. With minus 4, it will change to plus 4. So we have 1 here. 8 minus 6 is 2. Minus 3 is what we brought down here. Minus 4 is minus 8. Minus 2 is what we brought down here. 3 plus 4 is 7. 1 times 2 is 2. Minus 3 times minus 8 is plus 24. Then minus 2 times 7 is minus 14. 2 plus 24 minus 14 will give us 12. So this value is a single determinant. A single determinant, will find it to be 12. Then the next thing, now we have to find determinant with respect to x. Determinant with respect to s means in the column of s, instead of writing 1, 1, 2, we replace it with 1, 3 minus 4. Where is 1, 3 minus 4 coming from? I have explained it. 1, 3 minus 4 is coming from this constant 1, 3 minus 4. Alright, so because it's with respect to s, we replace the value of s, the coefficient of s in the equation by this constant. So the same procedure follow. By the time you find this determinant, you discover that this is 1, is what we brought out. This first row is covered. The first column is covered. You have minus 2, 2, 3, and minus 4. Minus 2, 2, 3, and minus 4. Then the second one is plus. Alright. Why is it plus? Okay. It's minus rather. Why is it minus? It's minus because this position is a 1, 2. And 1 and 2 add together is 3. 3 is odd. So it's minus. So this is minus, please. This thing you are seeing like this is minus. It's not plus. It's minus. minus 3. Okay, so the row is cancelled and then the column of 3 is cancelled. So we have 3, 2, minus 4 and minus 4 here. And that is why what we have here, 3, 2, minus 4 and minus 4. Then we have lastly minus 2 is what we have here. Of course, this is the extract of it. Look at it very well. Then 1 is what we brought down. Minus 2 times 4 is minus 2 times minus 4 is 8. Then minus 2 times 3 is 6. 2 times 3 is 6. So therefore, the next one is minus 3 is what we bring down here. 3 times minus 4. 3 times minus 4 is minus 12. Then we have 2 times minus 4 is minus 8. Minus 8 minus, and the minus that is supposed to be here from the reaction is going to be plus 8. Minus 2 is what we brought down here. Then 9 times 3 times 3 is 9. Then minus 2 times minus 4 is plus 8. So this is why we have this 8 here. So 1 is what we brought down. 6 minus 8 minus 6 is 2. Minus 3 is what we brought down here. Minus 12 plus 8 is 4. Minus 4. Minus 2 here is what we brought down here. 9 minus 8 is 1. So 1 times 2 is 2. Then minus 3 times minus 4 is plus 12. Minus 2 times 1 is minus 2. 2 plus this plus 12 is 14. 14 minus 2 is 12. Right, so with respect, determinant with respect to y, you see in the column of y, we replace the column of y with the constants 1, 3, and 4. In the column of y, we replace it. This is the column of y initially, minus 2, 2, and minus 4, but we are replace it. The column of y is 3, minus 2, and 3. We are replacing it with 1, 3, and minus 4. And that is what happened here. Yes, we replace it. So by the time you find the determinant, of course, by now you should be able to look at what I did. Look at it, look at it. By the time you find this determinant, this is how to find this determinant. You can pause the video, look at how I find it. The determinant is 24. Okay, that is the determinant is 24. Pause the video and look at it. By now you should be able to look at what I did here and understand why it is 24. Also, with respect to z, in the column of z, we replace it with the constant 1, 3, and minus 4. And we find the determinant again. You can pause the video, look at the solving, and you will find out that the answer is 36, step by step. Then, therefore, if we get the value of x now, x is going to be determinant with respect to s all over the single determinant. Determinant with respect to s we find is 12 from up there. Look at it. With respect to s is 12. And then the single determinant we find is still 12 too. Look at it here. So therefore, x is going to be equals to this all over this. 12 divided by 12 is 1. Y is equals to determinant with respect to y all over single determinant. The determinant with respect to y we find is 24. Look at it here. It's 24. Is here 24. Then from there we have divided by 12 is 2. Also, determinant with respect to z. With respect to z is 20 is what we find is 36. So 36 divided by 12. 12 is single determinant, which we find from up there, which is 3. So the value of s is 1. Value of y is 2. Value of z is 3. Okay. Now, this is a second example. This second example, what I'm going to do is that I'm going to stroll through it. All right. You can always pause the video at this point and watch it step by step. I won't explain it this time around. Okay, this one will be like a mini example practice for you. You see the way I'm strolling it slowly. Okay, so you can pause the video at any point and then watch what I did. Okay, pause the video at any point of this and then you see what I did. All right, can you see it? Step by step is what I did here. Then at the end, the value of s is 1, value of y is 3, value of z is 2. Okay, so Thank you very much. Don't forget to share with friends, subscribe. All right. Thank you very much.